of AI in real world. Thank you for your support for last two episodes. Your encouraging words were very helpful. That motivates me to bring different guests to my podcast. And today we have Akshay Mittal joining us for episode 3. Hello, Akshay.
Hey Sheetal, thanks for having me.
So Akshay brings unique experience and perspective where he works at the intersection of AI, security, and large-scale cloud system. So Akshay, in the previous episode, we were tapping into AI agent and AI architecture evaluation over the years, right? But
Mhm.
in today's episode, I want to uh, learn from you, from your real life experience, that how AI in real world under real constraints like latency, security, reliability, or trust are handled, right? All those things, how
Okay.
does one handle on that?
Yeah, I'll do my best. And yeah, before we get started, I wanted to share a small disclaimer, right?
Yeah.
I work for PayPal, but whatever I'm saying today is whatsoever no related to PayPal. I'm a part-time PhD
Awesome.
student and a researcher.
Mhm.
All this is coming through my PhD work and experience I'll be sharing with you all today. So just wanted to share that.
Yeah, perfect. And thank you for that disclaimer. It's very important when we talk about this real life experience. Absolutely, we don't want to get into any i- violation risk with the companies. So we'll keep it very generic. We'll talk about your research papers and your experience on the general areas and not specific to any company. Okay?
Sounds like a plan.
Okay, so let's dwell into it. Um, and my first question is exactly on the part what I introduced your introduction is large scale cloud system, right? Because your experience shows that you work with the systems
Hmm.
where they are transaction heavy as well as financial driven. So it's very sensitive area, right?
Right.
So I want to understand how does that building AI solutions or building AI system in this environment is different than the systems we built on the constraint environment.
Gotcha. Just to understand, designing AI for high grade, like financial grade for heavy
Correct.
platform, fundamentally differ from, like some less constrained environments, right?
Yes.
So I think, AI is fundamentally changes with the architecture, right? From maximum capability to optimizing for constraint. I
Hmm.
want to share a recent experience in my previous job, right? Where
Okay.
previous project where I was a sole architect, responsible for automating the infrastructure that
Hmm.
processes millions in client assets, right?
Wow.
And
Hmm.
the challenge was just not accuracy, it was like delivering that sub-second decision making without breaking the SLAs. And SLA was
Absolutely.
like 99.99 uptime,
Hmm.
Uh,
Wow.
Let me give an example. Maybe it might be easier, right? Think
Sure.
of
Yes.
it like airport security training, right? In a research lab, you might design a perfect AI scanner that examine every molecule of every piece of luggage.
Mm-hmm.
Incredibly accurate, right? But it takes 5 minutes per bag. That's useless at airport where you have to
True.
process 300
Yeah.
passengers per hour, right?
True.
You
Yeah.
need the scanner that's good enough, catches 95% of threats in 10 seconds
Mm. Yeah.
because speed matters as much as accuracy, right?
Yes.
Uh, in a recent published research, AI-driven real-time API security, which I presented at a San Antonio conference. It's one of
Mm-hmm.
the oldest conference, if you're aware. It's called ICCST. It
Mm-hmm.
was
Yes.
52nd year they were doing
Wow.
something around that. I documented this exact trade-off,
Okay.
and we achieved 95% threat detection accuracy using a lightweight gradient boosted trace model. that
Okay.
infer in under 50 millisecond versus a deep learning alternative that would take an additional 300 plus milliseconds of latency. And here what it meant with that practice, right?
Mm.
At my previous project, in our security checks, added every 200 milliseconds for every trade, right?
Back.
So we
Mm-hmm.
violated our service agreement and potentially cost clients millions during the volatile market.
Mm.
So we
Absolutely.
used a simpler model that was fast enough to run inline check every transaction as it happens,
Mm.
rather than a complex one that would require batch trading and introducing dangerous delay, right?
Mm.
So this architectural constraint actually led to $1 million cost reduction and compressed uh, timeline for our migration. Like instead of
Okay.
taking 24 months, it just took
Mm.
6 months. The
Wow.
lesson, uh, a model that's good enough and fast, infinitely more, right? Infinitely more is more valuable than the model is perfect, but breaks your
Mm-hmm.
transaction pipeline. I hope
Absolutely.
able to
Yeah,
answer.
that's a great example. The trade-off between cost or time versus the accuracy, and how do you handle it in the real life experience? Like, an airport was a great example. Like airports like SFO, Denver, Chicago, they
Right,
have
right.
like hundreds of flights every day, every hour probably, and then you have so many bags coming through. So in such situation, times value more than the accuracy, and there is a fine trade-off. And again, you put in how much accuracy we are sacrificing. That also important. You are not
Yeah, there's
sacrificing
always a trade-off, right?
50%. Correct.
Every
So
point of every step in this, right? There's always a trade-off. Sometimes it is speed, sometimes it is cost, sometimes it is efficiency. Yeah,
absolutely.
definitely they go hand in hand.
And when we do everything in small scale, right, you don't tend to attend to such situations because you are just looking at the accuracy and how fast I can develop my solution. So this changes your perspective when you go to the real life examples and try to use AI in such situations. So thank you for that insight.
Yeah, no problem. That's a great question.
So another aspect of this trade-off, or probably when we introduce AI into the production-like systems, is the reliability, right? How reliable is your system? What I have seen in the organizations lately, obviously I think everybody wants to catch up with the trend of AI, right? We are using AI, we want to do so much leveraging AI to enhance our product and everything. So it has become as an enhancement to our existing solutions rather than being the part of it from the beginning of the solution, because you cannot develop everything from the scratch, right? Because something new has been introduced. So in such cases, um, what I wanted to check is, as per your experience, where when we use AI, when does it become a reliability risk when we include AI without designing it properly, or without uh, making it a part of the entire architecture, like not just as add-on. So how do you evaluate that?
Right. And just to understand your question, right? Vendors and AI actually become a liability to a system than reliability if not
Correct.
designed well or carefully, right?
Yes.
So it's a great question, right? I feel like it becomes a liability the moment you treat AI as a replacement for your deterministic control instead of
Mm-hmm.
an argumentation layer, right?
Okay.
So
Can you elaborate more?
let me tell you
Mm.
a near disaster scenario, right? As
Okay.
I mentioned, I have over around 30 research paper in IEEE ACM,
Mm.
and
Mm.
this was actually one of my top five papers in a Arizona-based conference called SOSC IEEE. So
Okay.
the paper name, it's already published out there. It is AI Augmented DevSecOps Pipeline.
Okay.
So I my PhD work is around this area, right?
Mm-hmm.
DevSecOps,
Mm-hmm.
using AI and ML.
Mm.
So this was like a small paper where I documented a failure mode I observed during my work in modernization of cloud infrastructure. We
Mm-hmm.
deployed an AI-driven auto-scaling agent trained on historical traffic pattern.
Okay.
So think of it like a smart thermostat for our servers.
Okay.
It learns from the traffic was high, low, automatically added or remove computing power, right?
Mm-hmm. Mm-hmm.
So here is what went wrong. During a simulated DDoS attack, imagine somebody, intentionally flooding your website with fake traffic,
Mm-hmm.
crash it, right? The AI encountered the pattern it had never seen before, right? It
So there
confidence
was no history.
Right. It
Mm-hmm.
confidence score dropped below our threshold, but instead
Mm-hmm.
of feeling safe, it made a probabilistic guess. It thought this looks like a cost optimization opportunity and
Mm-hmm.
started shutting down the healthy server to save money, which
Okay.
amplified the outage.
Wow.
So it's like having a smart home system that have
Mm-hmm.
never seen a fire alarm before, right? When the
Correct.
alarm
Correct.
goes off, instead of recognizing danger, it thinks
It
it's a
shuts on.
loud noise, probably a party is going on, and turns up the music, right?
Mm-hmm.
Something like catastrophic misinterpretation, right? This is why, right, my research always advocate for guardrail first architecture.
Okay.
You layer AI on top of hard rules, right? In
Mm-hmm.
financial like systems, right, we never let a neural network have a final say on infrastructure shutdowns, right?
Okay.
There is always a deterministic circuit breaker, right? A rule-based kill switch that AI can inform, but never override, right? Because
Mm-hmm.
AI is always it's so non-deterministic at this point, right? So
True.
uh, think of it like AI is your advisor who can say, I think we should reduce the capacity, but the final decision goes to the
Is yours.
checklist. So is uptime above 99.9? Are error rates normal? Are we under
Mm.
active attack?
Mm.
If the answer is no, shutdown doesn't happen, regardless of what AI recommend. The AI can recommend, the rule decides. So having that rule
Okay.
always counts. I hope I was able to answer your question.
It does. And I like your framing of the sentences. Take AI as an advisor and not the decision maker, which is um, very unique as perspective to look at the AI solutions. Because I had another question on the top of it, but I will bring that up now because it relates to this topic. Um, what I hear from you
Mhm.
that human insight is irreplaceable in heavily regulated or security sensitive environment, right?
Yeah.
And this
Human
is one of
insight.
the example.
Right.
So my question on that is, where do you believe that it's like absolutely no chance of going, like you give one example, but how many scenarios or how many industries or how many areas where you think that human insight is irreplaceable and it cannot overtake, like how much AI gets matured, it cannot be replaced ever in this journey.
So where it is, see, I gave a similar talk, right, where how we can autonomous thing with AI, where
Mm-hmm.
there are opportunities, but there are a lot of if and when. It kind of depends on the use case, right? If it is not affecting you a lot, not affecting the business a lot in terms of financially or reputational wise, we
Mm-hmm.
can do something. Let's let's take an example, right? Uh, I'm a developer, right? I'm a full stack developer, and sometimes developer who build products and they are responsible for the support.
Mm-hmm.
And sometimes you have to be on call, right?
Mm-hmm.
And this is a good example, I say, right? Nobody wants to wake up at
Yeah.
2 a.m. and, drill the
Yeah.
logs,
True.
do this, do that. And, like you half sleep and you're figuring out how to do this in less time, right?
Mm-hmm.
So here is where this AI autonomicity can come in, right? As I mentioned, the rules are still in place.
Mm-hmm.
Uh, if we have enough metrics saved somewhere and see how we decided in the past, let's say like 100 use cases for the similar thing, and we have
Mm-hmm.
a confidence score, let's say above 95%, then we can give that kill switch to AI. Or maybe, if something is going wrong, oh, maybe go ahead and, automatically restart this for me, right? Restart this server or some very minor, which like, even if something goes wrong, it won't affect. I mean, obviously we have to determine those scenarios, but this is where, this would be a flip case where I would use AI to
You.
take care, something like that.
Okay. So tell me if I got it correctly and articulating it correctly. Historical data is very important for AI to learn the patterns, right? That's the bottleneck or heart of it, to learn see the patterns, understand the behavior and everything. So if you have huge historical data, it makes sense for AI to, on top of defining the rules, it might take some decisions which are not catastrophic, but where you see the AI is facing some unique scenarios which doesn't have history. That's where you want human insight to be, like human intervention to be done to handle those scenarios. So something like that, it has to be combination of both, and depending upon the scenarios, depending upon the situation we face in uh, individual systems, we have to take the decision. Is that correct summary?
Yeah, that's perfect.
Okay, cool. Thank you for that insight.
Yeah.
So I will move my questions to your comment on the DevSecOps, because you were mentioning that you work closely on DevSecOps, right? We have like our industry has evolved from ops to DevOps and now DevSecOps, which
Correct.
basically means security has to be part of the entire software development life cycle from the beginning and not as a final check.
Yep.
And now we are at the juncture where AI with DevSecOps is getting into, we are getting into that new phase of
Correct.
development, right? Where does you think AI genuinely helps to automate pipelines, work pipelines, or in regard to the security,
Mhm.
uh, or and where do you think that it just adding more noise rather than actual value?
Yeah, that's a great question, right? Like signal versus noise in AI and DevSecOps, right? So the real value is in contextual triage, right? Not automated remediation. So
Mhm.
let me paint a picture with some real example, right?
Sure, please go ahead.
So I had an opportunity to work with Springer Nature Conference, right? A research
Mm.
on leveraging generative AI for
Okay.
proactive security and CI/CD pipelines.
Hmm.
So traditional security scanners are like overly cautious, like spell checkers. They
Okay.
flag everything that might be wrong.
Hmm.
Even when context makes it obvious, it's fine, right?
Hmm.
In our experiment, standard SAST scanners flagged around 800 potential SQL injection vulnerabilities across our test corpus.
Mm.
So that's like a spell checker highlighting everything instance of there they are
Hmm.
in
Mm.
500-page document
Mm.
without understanding the usage is correct.
Okay.
Out of those, 89% were false positive. Test
Mm.
code, mock data, or already sanitized input. So
Hmm.
where AI excel in is in understanding the data flow lineage, right? I built a prototype using GPT-4 that doesn't just grep for pattern, it traces the variable journey through the code base, right? So
Okay.
here is a retainable analogy, right? Imagine someone reports, I saw a knife in a
Mm.
kitchen. A
Hmm.
traditional tool would trigger an alert, right?
Yes.
But an AI can reason it. Yes, there is a knife, but it's in a locked drawer in the kitchen. Is it in restaurant
Okay.
or it's a butter knife? Context matters, right?
Matters. Hmm.
Yeah.
Very good point.
So we reduced the false positive rate by 73%, right? For a security team drowning in 1,000 alert per day, that means
Mm,
they could focus on a real problem. They could
real
focus on
problems.
those real 200 change, a real thread, instead of
Mm,
like wasting time on those false alarms.
true. Okay.
However, I'm deeply skeptical for autofix agent. Here is why, right?
Mm,
In testing open source remediation tools, I found they have suggested fix that they are can they're like putting a bandage on a broken bone, right?
mm, mm-hmm,
They are syntactically correct, but architecturally flawed, right? For example, an AI might see error handling code that crashes and suggest wrapping everything in a try catch block.
mm.
The software engineer equivalent for if it make noise, just muffle it, right? So the program stopped crashing, but now it silently like swallows this error instead of
Mm,
fixing the root cause, right?
yeah. Mm.
So you pass your test, but 3 months later, you discovered
You
you have
face
been losing customer data because the exceptions were being hidden, right?
yeah.
This
Mm-hmm.
introduced what I called as silent regressions,
Okay.
bugs that passes the test but failed
Mm,
under production edge cases. It's like
mm.
far more dangerous than the original problem.
Yeah, absolutely. Um, th- just one thing popped up in my mind because when you were talking about, you mentioned that you use GPT-4 for developing something. Just interested in knowing when it is very sensitive topic related to security or financial, how much can we rely on these LM models? Or do you prefer to have something additional layer in the in-house to make sure that we don't expose our data to this large, because as you said, those muffled voices could be like hidden um, drawbacks of
Right.
this large models, right? We might not be, everybody is not aware of all those things. So how do organization, or in your personal experience, how do you think that that has to be, does that matter in this senses first? And if it matters, how do you take that call which models to be used? And or if we use this model, how do we make it more secure and don't leak our sensitive data to these models?
Yeah, certainly. I mean, all like in traditional, right? Like this architectures are changing every now and then,
Mm-hmm.
What I played around is all my curiosity as like a full stack developer to like getting into AI and
Mm-hmm.
others. You might find a better way, but what my perspective is like all the PI data or anything sensitive must be
Mm-hmm.
within the ecosystem, and you should explicitly mention any model, whether it is GPT, Claude, DeepSeek, Gemini, whatever, right?
Mm-hmm.
You need to create like a guardrails or set of rules that it should only keep everything within the same ecosystem, right? Without
Yeah.
exposing anything or sharing anything outside. Uh,
Okay.
that's why like running this pre-trained model yourself is better
Mm.
than something like for certain tasks. I mean, it depends on what you're running, right? But if
Mm-hmm.
you architect something, all the data within some vector database and create context, you're tracking it, and you're
Okay.
also using all those some there are some great LangChain tool will help you do that, track every request, how you prompted, how it is using temperature token, and how it is getting back, and how you
Okay.
change your prompt. You can kind of get everything uh, in a sheet and see how it is behaving. Just a little bit more work, but it's always worth doing that.
Got it. So again, security has to be inbuilt. The guardrail has to be in place before we expose our data to the LLM models.
Yeah, I mean,
Good.
measure twice, cut once, right? So always, yeah.
True. True. Very true. Nice phrase there. So I want to move to more in more details to this performance constraint, right? Because there are so many discussions happens about AI tools, AI systems. But everybody talks about how can we enhance our system, how can we make our system better, but nobody really talks about the constraint, performance constraint it comes with it. What I want to know is, how do you evaluate whether AI driven decision is worth the cost it adds, or the latency it adds, or the operational complexity it adds into the solution? What is, as we were talking in the earlier, our first question, the trade off, right?
Mhm.
How do you evaluate that? What kind of things one has to keep in mind to do that, to evaluate that trade off?
So the trade-off between in like were you talking about what kind of trade-off, like research versus production, or uh,
No, basically, when we decide to use AI as a decision maker, it comes
Mhm.
with the cost, right? With it comes
Right,
with
cost
the
is
additions, not only in terms of the money, but also in terms of it can cause a latency, or it can cause operational complexity in the decision making. Let's just take example of financial institute. Okay,
Mhm.
a bank probably. A bank is probably well, for the loan approval system, they are adding the AI agents or AI systems into the basis. So on what basis it decides whether to approve the loan or not, right? It comes with
Right.
that cost, right? It comes with this additional challenges, whether those decisions are made on the real grounds, or does it have the backing, like logical backing for its decision and everything, right? So it has its own constraints. So I'm looking for something similar example from you, or basically how one should evaluate this constraint when taking this, whether to introduce AI into this particular process or not.
Yeah, like basically like human in oversight and security, right? In critical systems, right?
Mm-hmm.
Where human oversight must remain in the maturity of AI or decision factors.
Mm-hmm.
So,
Okay.
so there are two non-negotiable, like explainability and policy governance.
Yeah.
So, I worked on a recent project where I designed a risk scoring system that can auto block suspicious transaction, right?
Mm-hmm.
As you were mentioning, cost is one of the things, but sometimes you also need speed and things. Uh, there are like various aspects where we need to, think what we need to involve. But the system while I was working, right? So
Mm-hmm.
imagine you're traveling abroad
Mm-hmm.
and you try to buy a dinner with your credit card, right?
Mm-hmm.
The AI sees two things, right? Unfamiliar location, unusual merchant
Mm-hmm.
category, different time zone, and it blocks your transaction, right?
Mm-hmm. Yeah.
And now you call the bank furiously, and here is the constraint. If we block a user, we must be able to explain why to the auditor or in the court, right? You
Mm-hmm.
can't say the neural network 47 then layer act, that's like police
Mm-hmm.
officers saying,
Mm-hmm.
my gut told me to arrest you. It doesn't hold up legally, right?
Mm-hmm.
So this is why I advocate for what I called human above the loop architecture, right?
Okay.
The AI can execute the block instantly for critical real time for fraud prevention when someone using a stolen credit card.
Mm-hmm.
But the decision must be decomposable into the auditable rules,
Mm-hmm.
right? Like think of it like a courtroom, right? The AI is a detective who makes the arrest, but the prosecutor needs to explain the jury, right?
Yeah.
This transaction came from an IP address in Russia. The card holder's phone GPS showed they are in Texas.
Mm-hmm.
The
Yeah.
purchase was for Bitcoin, which the card holder has never bought before. The
Mm-hmm.
transaction amount is 97% of the credit limit, right? Those are the facts human can verify and defend, right? So the human role shifts from being the operator, like too slow for real-time threats. By the
Mm-hmm.
time you manually review the fraud
Review everything.
alert, could be gone, right?
That's
Like
right.
it's the same
Mm.
thing, to being an architect who defines the ethical and legal boundary within AI operate, like a governance, right? So this, like, we cannot like outsource the moral reasoning of security policy to a model that can
Hmm.
only understand correlation, not causation, right?
Okay.
And AI might notice that people who log in at 3 a.m. are more likely to be a fraud. A human need to ask, are we going to penalize night shift workers or insomniacs where because of the statistical correlation? So that's the policy decision, not a mathematical one sometimes
Okay.
while
Yeah.
picking.
That
So
was that was a good example. Like you don't want to impact the genuine transactions who are actually working in the night shift and because of your some rules, right? Uh, I think, yeah, you touch base more on the governance and ethics into that. But I want to keep focus on our, I want to keep my focus on your expertise, especially on the security and latency and reality constraint, right? Whatever, or liability constraint.
right,
So I will just move back my question to the real life example, or probably difference between the real life and the theoretical example, because you keep mentioning you have done so many research papers, you have written so many research papers. So your work in that area is also very huge, as well as you work in a production system, right? With your clients, with your companies. What is the difference, like with what or in your experience, have you seen that one idea looks so good on the paper when you write a paper, but when it exposed to the real world traffic, like transaction volume or models what we use, and it fails, miserably fails continuously? What are these like, why does that happen, and have you faced such situations in your experience?
yeah, yeah. So it's like the clean data fallacy, right? I have been guilty of it myself in early papers, right?
Mm.
So here is a brutal reality, right? In my dissertation research on AI-driven like threat detection, I
Okay.
initially benchmarked against a NSLTDD, a beautifully curated intrusion detection database.
Okay.
It's like training a medical student on textbook cases where every symptom is clearly labeled and every diagnosis is obvious, right? So my
Mm-hmm.
models hit 98.7 accuracy in a lab.
Mm-hmm.
Then I deployed the same algorithm against real logs from
Mm.
distributed microservice,
Mhm.
uh, simulated, but real logs, right?
Realize. Okay.
Uh, which like it's to make up an example, right? Without disclosing. So they handle like delivery, right? Like
Mm.
Amazon, Home Depot, right?
Mm.
2,000
Mm-hmm.
plus delivery trucks,
Mm-hmm.
uh, 500,000 units, as they call it, SKUs daily, right?
Excuse. Yeah. Mm.
SKUs, right?
Mm.
The the performance collapsed to 64% accuracy.
Mm.
So it's like a difference between a driving simulator and rush hour traffic in downtown Austin.
Mhm.
So in the simulator, every car follows the rule,
Rules.
lane
Mm.
making perfect,
Mm.
weather
Mm-hmm.
is predictable. In
Mm.
reality, someone is texting you, there is a construction as always on I-35 with confusing signs.
Mm-hmm.
It's raining, a food truck is double parked, right?
Mm.
Why did my model fail? So real world data is asynchronous,
Mm.
inconsistent, and full of what I called operational debris.
Okay.
So
Nice
imagine
word.
trying to, reconstruct a conversation from a group chat where message arrives out of order. Someone's on slow Wi-Fi. Half of
Mm.
the messages are missing. Someone
Mm.
deleted theirs. Three people changed their username in mid conversation. The
Mm.
chat updated and changed its message format halfway through.
Mm.
That's what a real system logs look like, right?
Mm.
Missing timestamp, duplicated events because the service retry operation, schema drifts because team A updated their service, but team B didn't, right?
Mm-hmm.
Um, so yeah, right.
Yeah. These are
Uh,
the some
in
example why it
yeah,
fails in the real.
there are like some open source GitHub repositories on my profile. You can see, right?
Okay.
80% of the code base is data normalization pipelines, the unglamorous work of cleaning and standardizing messy data before ever touch the model, right? So uh, I try to like I'm trying to help few students at my university, Texas State, where I'm mentoring few students and uh,
Okay.
where we were talking about similar thing, and I said like the model is 20% of the work. The
Mm-hmm.
plumbing is 80%, right?
Mm-hmm.
So the academic papers and all, they shows you the beautiful finished kitchen. They rarely shows you the 6 month of plumbing, electrical work
True.
dealing with the code violation that happened first.
True. So my takeaway from your answer is one, use real, mocked up real data as much as possible to test your model. And second, even to create that mocked up data, you have to do, as you mentioned, like plumbing, electrical work, or sanitize that data to fit into your model, right?
Right.
Is that correct? Okay, got it. That's very interesting insight. Thank you for that. Um, okay, we are almost towards the end of our discussion. So I want to close our chat with one very interesting question, reflection on your experience, honestly.
Mhm.
What is one uncomfortable truth you will share with our audience, which you have faced about deploying AI into the system which handles real money or real users
Mhm.
or real risk, right? Real financial risk or security threat, as I put. What it would be? What is your one uncomfortable truth?
So one uncomfortable truth is that AI models are perishable goods. They have an
Okay.
expiration date, right?
Okay.
Let me explain with a stark contrast, right? So the
Sure.
traditional software doesn't rot. The
Mm-hmm.
tax uh, example, right? I was without taking the employers. So
Mm-hmm.
I worked on a product where it was a tax calculation engine, right?
Okay.
It will compute the same math in 10 years. If the sales tax in Texas is 8.25, the code that calculate price will work forever, right?
Mm-hmm.
It's like a hammer. You put in a toolbox for 50 years, it still hammers the nail, right?
Mm-hmm.
But the threat detection model, right? I tested, trained at a previous project, right?
Okay.
It started degrading in accuracy within 90 days. Can you,
Hmm.
why?
No. No.
The
Go ahead.
surface, the attack surface changed. The user behavior evolved.
Oh,
The
okay. Interesting.
adversary adapted. It's more like milk than hammer, right? It has a shelf life,
Hmm.
right? I
Okay.
often refer like what I call like I was reading somewhere. It's the author told it's like model half life.
Okay.
The time it takes for your model precision to drop by 50%, right? In in financial fraud detection, that
Hmm.
half life can be as short as 60 days.
Wow.
Here is
Interesting.
a good
Mm-hmm.
example, right? Imagine you train a fraud model in December 2025, last month.
Mm-hmm. Mm-hmm.
It learns that model looks like a holiday shopping, lot of retail purchases, higher transaction volume, travel bookings. Come
Mm-hmm.
February, People aren't
This is
shopping
one.
for gifts anymore. Your
Mm-hmm.
model starts flagging normal February behavior as suspicious because it
Hmm.
looks different from December, right?
Okay.
Your
Uh-huh.
false positive rates skyrocketing.
Goes up.
Or
Nice.
worse, the attackers adapt, right?
Mm-hmm.
They study
Yeah.
your blocks, figure out a pattern, and specifically crack attacks that look like legitimate traffic to your model, right? If you think
Mm-hmm.
about it, it's like a bacteria developing antibody resistance. Your
Mm-hmm.
medicine stopped working because the
Because.
threat evolved, right?
Mm-hmm. Yeah.
So in
Yeah.
in one of my Philadelphia, like USRC, if you heard, US RSC, if you
Mm.
heard about, I worked on a container security, which
Okay.
reduced the vulnerability patch time 60% across 200 research containers. So the document, we didn't just deploy a vulnerable scanner, we
Mm.
built a continuous monitoring system that detects when scanner itself become obsolete.
Okay. Yeah.
Deploying is the start line, not the finish, right? The
Mm.
real operational cost is continuous retraining the loop, the observability infrastructure to detect drift, and the human expertise to know when your model is lying to you, right?
Okay.
So think of it like maintaining a garden versus maintaining a statue. A statue,
Mm.
once finished, stands for decade. A garden require constant care, watching, weeding, pruning, or it dies, right? So
Yeah.
AI models are like gardens, not statues, right?
Yeah.
Uh, so, like while working with, I also volunteer for I host meetups. I w- I I meet so many cool people in
Mm.
various meetups I host for ACM, IEEE, Kubernetes, right? In the community,
Yeah.
Austin tech community. This is the
Mm-hmm.
first thing I share, right? If you aren't ready to support that life cycle, the feeding, the monitoring, the retraining, uh, you aren't ready for AI in production, right? Period.
Mm.
So
Okay.
too many teams treat AI development like a product launch, right? They
Mm.
train the model, deploy it, and throw a party, move on to the next project. What happens? 6 months later, they're shocked to find the performance worse than the
Mm.
role-based system they replaced.
True.
So the
True.
model didn't fail. They failed to understand that AI requires continuous investment, not one-time deployment.
Wow. That was a very different perspective I have heard so far, Akshay. Thank you for that. I like your analogy. Um, it's like a garden and not a statue. So you have to have the continuous monitoring. You have to evolve as the industry evolves, as the system evolves, as the tool itself evolves, right? Because even AI is learning so many things. There are new features added into AI. And as you correctly mentioned, even the attackers are learning as we are also learning about it. So they are also becoming smart and
Right.
coming up with the new threads and everything. So I really like that perspective. Thank you for that. It's
Yeah,
great.
thank you. So great,
So
great question.
thank you for all the insights, but I don't want to let you go without my rapid fire round. So I have few rapid round fire questions for you. Hope you don't
Okay,
mind.
sure.
Okay. So my first question is SLM or LLM? If you had to choose today for a high traffic production system, what will you choose?
I would have like a master slave, small SSL, small LLMs versus large, because easy, they do one good thing and you have a manager to take care of it. So that architecture is kind of interesting. I want to learn more about it and play more with it. I feel it's more
Okay.
efficient than large LLM. It actually depends on the scenario too, but sure, right?
Okay.
Let's if we
It's a
consider.
rapid fire, so you have to choose one.
Okay, my bad.
SLM. Okay. Next one. Which one do you lose sleep over more, latency or accuracy?
Latency.
Okay. Do you want to explain the like 30-second or should I move?
I mean, that's why I took a thing like both has its own explanation, right? But I
No,
feel like
that-
latency is really important because everything is so speed these days. I mean, on the
absolutely.
flip side, accuracy too. So it's like chicken, chicken
Chicken and egg
egg.
situation.
Yeah.
No. I don't want you to lose sleep. Hopefully, you don't have to get into those scenarios. Okay, next question. Which is more dangerous in security critical AI? False positive or false negatives?
Um, false negatives.
Okay, yeah, I agree. I think having false positive is better to check more rather than having one false negative and breaking the system. So,
Right.
cool. What's your default instinct? Build it yourself or buy a managed AI service?
You know the answer, I guess.
Build.
I always like prefer DIY where you have more
DIY.
controls and I mean, see, I feel like even if you're failing, you fail fast, right?
Mm,
Nowadays, like it's good to fail fast, learn from your mistake, and move on, right? So
well, yeah,
because everything
absolutely.
is so fast.
True. I totally agree on that. Models, data, or operation. One thing engineer underestimate most about production AI.
Could you repeat that question, please?
Uh, Models, data, or operations. One thing engineers underestimate most about production AI.
There's unexpected outcomes, right? Like, um,
Operation, I guess,
yep,
probably.
yeah, operation.
Cool. Thank you so much, Akshay. It was very fun and at the same time, so much learning from you. So, thank you for your time. I wish we could continue this conversation for another hour, but I know you also have other commitments. So, thank you for your time once again. Thank you, everyone who is watching our episode. And please feel free to send us your questions, and we'll be happy to answer your questions. Thank you.
Thank you for having me, Sheetal. Have a
You have
great weekend. Thank you.
you
Bye.